Hey guys, all right, so I'm gonna go through the 10 problems from the worksheet where we're gonna find slope, find the y-intercept, and write a slope-intercept equation for each of these linear functions. So number one, I have a graph, and on a graph, I know I need to find two perfect points. So I'm gonna start by looking at my graph and I see a perfect point right here. This is 4, 3, and I see a perfect point right here. This is 8, 1. Now, you could use these points, you could use any other points, you will still get the same answer because a linear function has a constant rate of change. So no matter what, you're still going to get the same answer. So I'm trying to find the slope. I can use my slope formula, or I could use rise over run. Since my graph is going by units of 1, it goes 1, 2, 3, 4, 5 on both the x-axis and the y-axis, I'm going to go ahead and do rise over run for this problem. But in future problems, I'll do the other strategies so that you can see how to do both. All right, so to get from one point to the other, I'm going to need to go down. And since I'm going down, that's going to be -2 because I went down 2 units. And then I went to the right, and that's 1, 2, 3, 4 units. So that's my rise and my run. The rise is the amount that I go up and down. So in this case, this is -2. And the run is how much I go from left to right. And in this case, that was +4. So my slope is -2 over 4, which simplifies to -1/2. So my slope is -1/2. That's part one. Now I need to identify the y-intercept, and I do that simply by looking at the y-axis, and I'm trying to see where my line touches the y-axis. And over here I can see that it's touching the y-axis at +5. So my y-intercept B is +5. And then all I need to do is take those two numbers and put them into my slope-intercept equation. Now remember, the general form is y equals mx plus b. And all you need to do is replace the m and replace the b. So I have y equals -1/2 x plus 5. That's my final answer. Y equals -1/2 x plus 5. Problem 2. I don't have a graph here, I have a table. And on a table, we're going to pick 2 points. When we're finding the slope, we got to pick 2 points, any 2 points. So let's see, let's do 1, 19 and 3, 11. Any 2 points is going to work. And I plug them into my slope formula. Here, I have my x1 and my y1. I have my x2 and my y2. So I plug that in. I have 11 minus 19 over 3 minus 1. 11 minus 19 gives me -8, and 3 minus 1 gives me 4. 2, I'm sorry, 2. So my final answer, when I divide -8 divided by 2, I get -4. So my slope is -4. All I did was I plugged everything into the slope formula. Y-intercept on a table, well, you just have to look and find wherever x equals 0, which is right here. Wherever x equals 0, that's your y-intercept. Sometimes it shows it to you, sometimes it doesn't. Here we got lucky and it already gives it to me right away. So I know B is 23. So my formula is y equals -4 x plus 23. That's number 2. Number 3, I have a graph again. Like I said, last time I used rise over run, but here I'll show you guys how to do this using the slope formula. So first things first, I need to find two perfect points, and I see one at 1,000, comma 2,100. You have to be careful. The y-axis is going by 100. So this is 2,100, this is 2,300, and so on. And the x-axis is going by 500s. So if I fill in the blanks over here, this is 2,000. All right, and then let's see, I see another perfect point at right here, 3,000, comma 2,300. And like I said, you could use any two perfect points. These just happen to be the ones I chose. You could choose any other and you'll still get the same answer. I'm going to plug them into my formula. Now, if it helps you, and it does, for me, it's very helpful to put those points into a table so that I can look at it as a table. So my table would be 1,000, comma 2,100. That's my first point. And then 3,000, comma 2,300. That's my second point. Now, same as the previous problem, I'm just plugging everything in. So I have 2,300 minus 2,100 over 3,000 minus 1,000. And now you can use your calculator, you can do quick math in your head, but either way you should get 200 for the numerator and 2,000 for the denominator. So I have 200 over 2,000. When you divide, you get m equals 0.1. Now, in this case, I'm using a decimal because my units are dollars. And money, we count with decimals. We don't use fractions for money, we use decimals. So in this case, my slope, I'm going to use it as a decimal. I get 0.1. All right, and then the y-intercept, I look on my graph. Where is the graph touching the y-axis? Right here. That's my y-intercept, which is at 2,000. So B is 2,000. So my equation is y equals 0.1 x plus 2,000. Okay. So that's how we do the slope formula on a graph. Moving right along to number 4, I have a table once again. So I already know for a table I need to pick 2 points and use my slope formula. So let's go with, let's see, 4 and 6. Why not? So I have y2 is 43, so I have 43 minus 29 over 6 minus 4. All right, 43 minus 29 should be 14, and 6 minus 4 gives me 2, and 14 divided by 2 is 7. So my slope is 7. But now, okay, there's a little bit of a problem. If I'm looking in my table, I can't find the place where x is 0. So when x is 0, I don't know what y is going to be. So here's where we're going to use a strategy that'll help us figure out that answer. What we're going to do is we're going to use the slope-intercept equation, y equals mx plus b. We're going to use that to our advantage. And what we're going to do is we're going to pick a point on this table. Any point will work. But let's say, let's have fun with it. Let's do 7, 50. Okay, on that point, 7 is my input and 50 is my output. And coincidentally, in my equation, I have a place for my input, which is x, and I have a place for my output. So what I can do is I can fill in everything except b. So for y, I'm going to plug in a 50. For m, I'm going to put in a 7 because I already found m. Remember, We calculated m in the previous step. So I can plug that in. I can also plug in my input, which is also 7, and that comes from the table. And then all I have left is b. And that's what I'm going to solve for. I'm going to figure out what is the value of b. So in order to do that, I'm going to multiply 7 times 7, which is 49. So I have 50 equals 49 plus b. And now to get b all by itself, I can take away 49 from both sides. 50 minus 49 gives me 1. So I know that b equals 1. So whenever your table doesn't have the y-intercept in it, you can find it by using the slope-intercept equation and solving for b. So I have my slope, I have my y-intercept, now I can write my equation. Y equals 7x plus 1. There you go. So this kind of problem does have one added extra step, so it's important to understand how to do that. All right, and then finally I have one more graph. So we're still going to do the slope and the y-intercept, and I'm looking for perfect points. This is a little bit blurry, and anytime that happens, you got to go for the most obvious ones. And here I noticed that right here is a very obvious one. This is 0, 4. And here's another one. This is -5, 0. I could use the slope formula, or I could use rise over run. If you're using the slope formula, you would plug in the values from your table. So since I have -5, 0 and 0, 4, my slope formula would be 4 minus 0 over 0 minus -5. Okay, since I have that double negative in the denominator, this is really 4 minus 0 over 0 plus 5. 4 minus 0 is 4, 0 plus 5 is 5. I have 4 over 5. I have a fraction, I'm going to leave it like that. I don't need to turn it into a decimal because I don't have any values of units that need to be decimals. So I'm just going to leave it as 4 over 5. If you did rise over run, you would get the same answer. Between these 2 points, I go up 4 units and I go over 5 units. So rise over run would be 4 over 5. I would get the same exact answer. Now my y-intercept could be a little more difficult to see it on this graph, but remember at the end of the day, you're looking for the place where your line intersects or crosses the y-axis. So notice, my line crosses the y-axis at the positive 4, 0, 4. So that is my y-intercept, 0, 4. So B is 4, because it's right here on the 4. So now I have all my information. I go ahead and I write my equation. Y equals 4/5 x plus 4. And that's it. Okay, that's number 5. Now from here on out, it's going to be more questions that look like what it would be on a test. So let's get right to it. So on a test, when you have a multiple choice question, we got to use those testing methods and all of those strategies to help us out. Because at the end of the day, we are trying to figure out the equation, but we can also do process of elimination once you kind of see which answer choices you could get rid of. So the first thing I notice about this graph is the y-intercept. I'm looking for the place where my line crosses the y-axis, and that happens right here at the -2. So my b is -2. And since I know that my equation is going to be y equals mx plus b, I'm going to look at the values they have as b. In a, they have a 5. I know that's wrong because I'm looking for a -2. So I know A is wrong and I know C is wrong because they have the wrong y-intercept. So see, not only am I using what I know, I'm also doing process of elimination at the same time. Now between B and D, The difference is the slope. So now I have to look for my perfect points and find my slope. I already know one perfect point because it's the y-intercept. Okay, so this is 0, -2. And looking at my graph, I see another perfect point right here at 5, 0. If I make a table, this is going to be 0, -2, and 5, 0. So in my equation, I would have 0 minus -2 over 5 minus 0. My double negative becomes a positive, so this is 0 plus 2 over 5 minus 0, which is 2 over 5. And if I use my calculator and I divide, 2 divided by 5 is 0.4. So right here, they give me the correct slope and the correct y-intercept, so I know D is my answer. Number 6 is very, very, very similar. So I'm going to use a very similar strategy. In my answer choices, the only thing that they're changing is the slope, because they keep the y-intercept the same. So I can't use my y-intercept to help me out, but what I can do is I notice that I have +2 and +1/2, but then I also have -1/2 and -2. So I need to look over at my graph and I need to think about it. Is this a negative graph or is it a positive graph? And if you're not sure, you can always remember Slope Man. Slope Man has his eyebrows. One is negative, one is positive. And when I look at the shape of my graph, it matches with his negative eyebrow. So that's how I know that the slope is negative, which means answer choice A and answer choice B would not be correct. But now I need to figure out if it's going to be C or D. So I do everything I've been doing. I'm going to pick 2 points, -3, 3, -2, 1. You could do rise over run, or you could do the slope formula. I'm going to keep using the slope formula because I know many of you like it better. My 2 points are -3, 3, and -2, 1. So I have 1 minus 3 over -2 minus -3. I have a double negative, so I have to fix that. So this is 1 minus 3 over -2 plus 3. 1 minus 3 is -2. -2 plus 3 is +1. So I get -2, which matches with answer choice D. There you go, problem 7. And then for problem 8, it's kind of a similar problem, but now we're going the opposite way. Now I have an equation and I have to match it to the correct graph. So I'm still going to use process of elimination. From my equation, I know that the slope is -2 and that the y-intercept is -1. So the first thing I'm going to do is I'm going to look at the y-intercept of all of these lines. And lo and behold, there's actually only one correct answer because over here the y-intercept is 2. Down here the y-intercept is -4. Over here it's -7, 0, -7. And over here it's 0, -1. And that's exactly which one I need. Now, if you did it the other way and you were looking at slope, you would know that the slope is negative. So you're looking for a negative graph, which means C and D are out. And then between A and B, B is the only one with the correct y-intercept. So B is my answer for problem number 8. All right, problem 9 is 3 parts. It's a real world scenario, so let me read it out loud real quick. Andrew wants to buy a smartphone that costs $500. His parents will pay for the phone, and Andrew will pay them $50 each month until the entire amount is repaid. The loan repayment represents a linear situation in which the amount, y, that Andrew owes his parents is dependent on the number x payments he has made. So part A, what is the slope and what does it mean in this context? All right, I have a lot of points to choose from in this problem, but they already gave me 2, so I might as well use those. I have 0, 500, and I have 1, 450. I could use my slope formula. So this would be 450 minus 500 over 1 minus 0, which is negative 50 over 1. So I know my slope is negative 50. So I could have used that. I could have used rise over run. You can also see it in the word description. We know that it's $50 each month. So there's 3 ways to find the slope in this problem. Now that I have the slope, let's figure out what it means. So I need to use my units. I know it's negative 50. My y-axis is money, dollars. My x-axis is months. So this would be negative $50 per month. And that represents the amount Andrew pays back each month. All right, next up I need to figure out what is the y-intercept. And on this graph, I see it right here. It's the place where it touches the y-axis. So my y-intercept is 500, and my units are dollars. So it's $500. All right, so I know that the y-intercept is 500, and then the units are $500. And what does this represent? Well, if I look at my problem, I know that the smartphone costs 500. So 500 is the amount, the initial amount that Andrew owes his parents. Okay, so at the beginning, he owes $500. And then finally, I need to know what's the x-intercept. So for that, I'm looking for the place where my graph touches the x-axis, which is right here on the 10. So the x-intercept is 10, and my units is months. And this represents the amount of time, so how long it takes Andrew to pay off the phone. Because when he gets to 10 months, his amount is down to 0, so he doesn't owe any more money. All right, so that was problem 9. And finally, problem 10. The table below is of a quadratic function where x is measured in seconds and g of x is measured in meters. So it's telling me that the input is seconds and g of x is meters. And it wants me to know what is the approximate rate of change over the interval 0 is less than or equal to x is less than or equal to 4. Okay, so what is going on here? I need to find the approximate rate of change. So I know I'm going to use my rate of change formula. And the interval is telling me which 2 x values to look at. So it's telling me to look at when x is 0 and when x is 4. And all I'm going to do is I'm going to plug those values in. So my y2 is 25.1, y1, sorry, is 2.3, x2 is 4, x1 is 0. Okay, there's decimals here, so yes, you may use your calculator. And if you do 25.1, which I just realized I wrote incorrectly, here we go, 25.1. So 25.1 minus 2.3 gives me 22.8. And then 4 minus 0 is 4. When I divide that, 22.8 divided by 4, I get 5.7. And I know that my units are meters per second, which means D is my final answer. All right, so those are the 10 problems from the worksheet from today. Hopefully this cleared things up and it becomes easier for you to understand how to do these problems so that you're prepared to finish up your quiz and succeed in class. Bye, everyone.